Change in river flow. There are things we know and there are things we don't know. In 1940, the USGS, United States Geological Survey, started monitoring river flows on a number of tributaries to the Minnesota River. And we have that data starting in 1940. And what we know is that of those tributaries, either to the Minnesota or Mississippi River, some of them have not changed in the amount of flow, the annual flow that they have. We also know that about half of them have changed, and that change is very large. They've doubled the amount of flow they have per year in their rivers since 1940. So we know there's a change. It's measured. It's not a hypothesis. It's a measured value. Then the question becomes, well, why have flows changed? And we certainly know that we've done a lot of land use changes, and some of those land use changes are consistent with increasing water flow, like drainage. We also know that the climate is a little different. And I don't mean global climate warming, I mean we have more rain now than we did in the past, at least somewhat more. We've been able to separate out and make estimations about how much that change in contribution from climate and land use and drainage is contributing to those changes in water flow. And what we found is that the increase in rainfall can describe less than half of the increase in flow. And that's really not a surprise because remember I told you that some watersheds do change and some don't change, and yet they all have some change in rainfall. So there's something else driving the change in flow beyond just an increase in rain. And part of it is the crops we're growing, and part of it's what we're doing to those depressional areas that used to hold water. So here's the other thing that has changed dramatically since 1940. And if you have any farmer friends who remember back to 1940, they'll all verify this change, and that is, in 1940, in Minnesota, we grew almost no soybeans. Soybeans are now 50% of the row crop agriculture in the Minnesota River Basin. And it isn't that we're farming more land, we're farming about the same amount of land, but we've replaced and changed the crops. So a large portion of the land used to grow alfalfa, rye, oats, winter wheat. All of those crops are green and growing like this grass here early in the year. Green and growing crops suck up water and they transpire it or it gets evaporated back to the atmosphere. Soybeans aren't planted until mid-May, and they're really not big and growing until June. Therefore, there's no water being evapotranspirated back to the atmosphere by soybeans. That water then is available to either infiltrate into the ground or run off. So that's one change we know. And the other is the drainage. We know that we know that over the last 150 years we've been installing artificial drainage, and we continue to install artificial drainage in places like that held ponded water and evaporated it away. We're now funneling that water to the rivers. Both of those land use changes, the crop conversion and the drainage, contribute to more flow in the rivers. Our current estimation is that more increase in flow has been caused by the drainage and changing the ponded water than by the crop conversion. That's an answer for a yearly basis. We also know that seasonally, in the months of May and June, that crop conversion is a more important at that time of the year conversion, because that's when it's taking place, or when it's not taking place. There's no evapotranspiration in May and June where there's soybeans. And that seasonal component is important because our largest impairments for sediment occur in the months of April, May, and June. The largest load of sediment to Lake Pepin is in April, May, and June. So those changes in flow that are occurring in April, May, and June may be the most important changes, and therefore the role of crop conversion ultimately for water might be more important than the drainage. We don't know that yet. We know that both of them have caused that change. Why does it matter? So what? We change flow. There's more flow in the rivers. Big deal. Rivers are the size they are because they have the amount of water in them that they have for a given slope. And they're as wide as they are because that's how much energy they carry and they can widen. When we put more water in them, they aren't used to that amount of energy. they get wider. When they get wider, that sediment ends up as suspended sediment, creates turbidity, and ends up in Lake Pepin. So widening of the rivers is a consequence of increased flow and therefore increased suspended sediment and turbidity loads.